So when we add up the terms of a sequence, we get a series. All right, so if you remember, a sequence is an infinite list of numbers, right? That's how we defined a sequence in the last lecture, in the last section. And so now we're just adding up all those terms to create a series. But how do we add up an infinite number of numbers? What are we supposed to do to do that? Well, let's look at example 1 and just think about how you would do this. Obviously you can't add up an infinite number of numbers, but if you were asked to find, what this sum is, you'd probably just start by taking the first two numbers and adding them together, and then adding on the next number, and then adding on the next number, and adding on the next number, and so on. So what you're doing when you do that is you're creating a sequence of partial sums, right? You add the first two numbers, you get a result, right? That's a partial sum. You add on the third term, and you get another result. That's another partial sum. And so what we end up with is a new sequence of numbers, and if that sequence converges, then the series converges. But I'm getting ahead of myself. All right, let's take a look at this. So I'm just going to create a little table of these partial sums, right? So I'm just going to take n will be my nth partial sum, and I'm going to call the partial sum s sub n, right? And I'm going to define s sub n just to be the sum. I'm going to use the sigma notation from n equals 1 up to some. Actually, I'm going to change that. I'm going to make it because n is the number of terms that I'm adding up. So I'm going to create a new index I. So I'm going to add the terms from I equals 1 up to n, right? So then n is the number of terms that we're adding, and we're going to add 1 over 2 to the I power. Okay. And that's what I'm calling a partial sum. Partial sum. Okay. So my first partial sum is when n equals 1. So that's just one term, so it's just a half, right? So S1 is just a half, right? So, and then when I add the first two terms, I get 1/2 plus 1/4. Oops, 1/4. Okay. And what do I get? I get 3/4. Okay, so that's my second partial sum. And then the third partial sum will be 1/2 plus 1/4 plus 1/8. Now I could just take, I already know 1/2 plus 1/4, and I could just add on the next term, which is 1/8. But when I do that, I get 7/8. Okay, and then my fourth partial sum is just going to be the sum of the first four terms, right? So 1/2 plus 1/4 plus 1/8 plus 1/16. If I add 7/8, oops, that's supposed to be 1/16. I get 15/16. Okay, so you can kind of see a pattern happening here, right? We've got these fractions, and the denominator is just a power of 2, and the numerator is just 1 less. So we could actually write a, we could just keep going, and for the nth term, s sub n looks like it's going to be 2 to the n minus 1 over 2 to the n. Okay? That's just my guess. So, I think that's a pretty good guess. All right, so if we want to find the sum of the series, what we want to do is take the limit as n goes to infinity of all these partial sums. So, and the partial sums are just adding up the first n terms, right? So if we let that n go to infinity, then we'll get the sum of the whole series. Now in this case, it looks like the sequence that's produced by these partial sums is going to 1, right? Because if this is true, that the nth term is s to the n minus 1 over 2 to the n minus 1 over 2 to the n, then the limit is just going to be 1. So this is going to add up to 1. So that's kind of cool. I want to show you a little geometric representation of this particular sum. So let me see here. I'm going to bring this up. So imagine that the whole square represents 1, okay? And then we're putting in these blue pieces. So the first piece we put in is half of the square, right? And then we put in the next piece, which is a quarter of the square. And then we add the next piece, which is an eighth of the square, and then a 16th, and then a 32nd, and a 64th, and so on and so on. And you can see geometrically here that it's going to 1, right? It's going to add up to 1. So there's also, I have another thing I wanted to show you related to this problem. So I'll leave this here for you to look at now that you know how to add up a series, and in particular this particular series of 1/2 plus 1/4 plus 1/8 plus 1/16. This joke will make sense to you. So I'll leave it here for you to look at.